12. I look at number 12 and the first thing I see is there are outer exponents, so I have to handle them first. So the first parenthesis is not going to change. But the second parenthesis is going to become 2 to the second, b to the first to the second, c to the negative third to the second. And this parenthesis is going to become negative 3 to the third, and c to the fourth to the third. Now I'll go and I will evaluate 2 to the second and negative 3 to the third, and I will also multiply the double exponents. First parenthesis still has not changed. So it's negative 5, a to the second, b to the fourth, times 2 to the second is 4. Multiply the powers here, you have b to the second. Multiply the powers here, you have c to the negative sixth, times negative 3 to the third is negative 3 times negative 3, which is 9, times another negative 3 makes negative 27. Negative 27. And then 4 times 3 gives you c to the 12th. Now I'm going to do the coefficient multiplication. Negative 5 times 4 times negative 27 is positive 540, and I saw that on a lot of your guys' papers, so you did really well with that. 540. Then to multiply the a's, I look for a's, and there's no other ones, so I just have a to the second. For the b's, I have b to the fourth and b to the second. If I add those exponents, I get b to the sixth. And for the c's, I have c to the negative sixth and c to the 12th, which if I add the exponents, I get c to the sixth. And that is the final answer for 12. One of the things I noticed on some of your guys' papers is that you, excuse me, left your final answer like this. You have to finish it up. Your final answer should have all the coefficients multiplied and reduced. There should be one of each variable in your final answer. So you shouldn't have more than one A, more than one B, or more than one C. Number 14. Number 14, we have 9 p squared q to the negative third over 27 p q to the third r to the negative second, all raised to the second. Okay, now I know I have to distribute the exponent, and I noticed that a lot of you did distribute it right away, but then you got this giant number because 27 to the second is a giant number. So for me personally, because 9 and 27 reduce, I'd probably reduce it first just to make my life easier. So I know 9 over 27 is 1 over 3. So I would change this to be 1 over 3 p squared q to the negative third over p q to the third r to the negative second all to the second. Now from here you can decide, do you want to deal with the negative exponents or do you want to distribute the exponent on the outside in? Either way wouldn't make a difference. Since I usually distribute first, that's what I'll do. So I'm going to have 1 to the second, p to the second, q to the negative third to the second, over 3 to the second, p to the first to the second, q to the third to the second, r to the negative second to the second. So now if I do the work that's left here, 1 to the second is 1, 3 to the second is 9, so I have 1 over 9. Multiply the inner outer exponents, I have p to the fourth, q to the negative sixth, in In the denominator, I have p to the second, q to the sixth, and r to the negative fourth. Now before I do any adding or subtracting of exponents, I'm going to move any negative exponents to the opposite side of the fraction bar. So the q to the negative sixth is moving down to be with the one that's already there. And the r to the negative fourth is moving up. Those are the only two movements you're making. So in the numerator, I have 1, p to the fourth, r to the fourth, over 9, p to the second, q to the sixth, and another q to the sixth. Now I can clearly see the p's have to be subtracted. 4 minus 2 is 2, so it's going to be p to the second in the numerator. R to the fourth has nobody to work with, so r to the fourth just stays there. And then q to the sixth and q to the sixth, they add and make q to the 12th. That is your final answer, unless you want to take the 1 out of it, because you don't need it. And that's number 14. Great job, guys. Have a good day.